So now on to question 8. This relates to P6 radioactivity, and the first question is concerned with the use of fluorine as a radioactive tracer in a PET scan. And the question says, explain why fluorine 18 must be produced close to the hospital where it is used. Well, with a PET scan, we use fluorine to actually contaminate the patient with a radioactive substance, and we don't want them to stay radioactive very long. So therefore we use fluorine 18 because it's got a short half-life, and so it must be used as soon as possible after making in order for it to be effective. But the short half-life means that the patient, as I say, doesn't stay radioactive for more than a few hours. So 1 mark for short half-life, 2nd mark for being used as soon as possible. The next question was to do with internal and external radiotherapy, and the reason why alpha is used for internal radiotherapy and gamma is used for external radiotherapy. Now, alpha is short range. Most students got that. But then some students said that the reason it is short range is because it's weak or because it's not very ionizing, and that is incorrect. Alpha is highly ionizing, and that's the reason why it can't travel very far, because it interacts, it ionizes the atoms in whatever it is travelling through, whether that's the oxygen and nitrogen atoms in air, or whether that's the atoms that make up the skin or the blood. So that's the reason it can't travel very far. So 1 mark for saying that it's got a short range, okay, or it is got a low penetration. That would also get you the mark. The 2nd mark is for stating that it therefore needs to be close to the tumour. For gamma, gamma is the opposite to alpha. It's got a long range because it is weakly ionizing. It doesn't interact as much as alpha does with atoms. So it's got a long range and it's got high penetration. And that's the reason why it can get through the skin. It can travel meters in air. You might have seen in lesson the fact that it can get through aluminium and you need a thick sheet of lead to actually stop it. So for the 2nd mark, you state it can get into the body from outside, and that's why it can be used for external radiotherapy. Part B of question 8 was concerned with nuclear fission. So this is the process that occurs in nuclear power stations, and the answer is neutron. A neutron is fired at a uranium nucleus or nuclei to cause it to split under a controlled chain reaction. The final question was 3 marks. It was a calculation question. You were asked to calculate the kinetic energy, you were given the kinetic energy of 1.2 times 10 to the minus 11. You were given the mass of 1.4 times 10 to the minus 25 kilograms, and you're asked to calculate the velocity. First of all, check that the units are in standard form, so joules and kilograms, so there's no need to change that. So first of all, using the FIFA acronym, F is formula, so we write down the equation for kinetic energy. We then insert the values that we are given. Kinetic energy and mass. You get 1 mark for doing this correctly, inserting the values correctly into the equation. The 2nd mark is we need to fine tune, okay, so the 2nd F in FIFA. And here is where we've rearranged it. Now you can rearrange the equation before you substitute your values, that's fine. But in this case I've rearranged it after I've substituted the values. And that gives me an equation there for v squared. Obviously I'd have to work this out and then take the square root. And then the A for my answer. And then finally I would write that in the answer space. just use a bit of common sense then. Look at that value. It's a very large value, 1.3 times 10 to the 7, just under 10% compared to the speed of light. But we are talking about tiny subatomic particles. These travel at great speeds. So don't be alarmed by the fact that it is such a large number. But of course it can't be bigger than 3 times 10 to the 8th. That would be incorrect, because nothing can travel faster than the speed of light.